but chalet-style homes also create lots of opportunities in the process of construction, structural opportunities. There's a couple examples when you're creating really large openings in a modular home and really high peaks in a modular home. So one of the first things is, in a chalet home, you typically have a vaulted open ceiling, and that might be 15 feet, 26 feet. Now you have to transfer load at 2 points, which is usually the end wall and that interior wall. That interior wall is usually a loft area, and there is a huge concentrated load at that loft area. That concentrated load has to go from the roof down through the floor, down through the basement. Many times this may exceed 26,000, 32,000, 50,000 pounds. So you have to make sure that you've got the adequate lolly column support in the floor to support this load. On the front wall, that load's got to get transferred down, and many times there's something in the way. There's going to be a fireplace that on that chalet that the customer wants to put a fireplace. It could be that the factory, instead of transferring load at the peak, they transfer it to two side, I'm going to say sistered microlam on the sides, because there's window structures in the front that we can't transfer the load vertically down. So on the front of that chalet, so you don't have wind pushing in, you might have something, an apparatus called a wind column that's built into the structure. And that's typically achieved by sistering 2 to 3 pieces of LVL. The LVL is probably going to be thicker than that front wall assembly. That wall assembly is going to be typically built out of a 2x6, and this LVL might be a 2x10, it might be a 2x12. And so now you're going to have that little bump onto the interior that you're going to have to prepare your customer that is going to become part of the way the house is designed. There may be a fireplace at the bottom, and so now you're going to have a temporary header put in place at the factory, so that, and the way that works is the modules are installed together. There are beam pockets essentially installed on either half of the house to support the load during transport. They will put cripples or supports in at the mating wall area. On site, they will have shipped typically 2x6s, 2x8s, or 2x10s that will be triple sistered together. You will insert that beam, that header into that beam pocket, then you will pull out those temporary supporting members, and now you're able to install that fireplace, that door, that window, whatever it was on the mating wall area. The next aspect of installing chalets are, how do you install that roof assembly to begin with? You have factories that have come up with a number of different engineering ways to do it. So for instance, one factory will install that chalet roof as one complete panelized assembly, or multiple pieces of panelized assembly. The great thing about that is, on the interior, from the top plate of the outside wall to the peak, I have one single width of structural or of roof joists. It could be a 2x12, it could be a 2x10, but now I have airflow going all the way from the eaves to the peak. I have factories that will actually do this as a hinged roof, so they will hinge part of it and do a flip. The problem is now I have solid members blocking airflow from the eave to the peak. And so I'm going to have to either drill it, or if they didn't do an offset, I'm going to have to drill that, and now I'm sitting 24 feet in the air, 15 feet in the air, and I have to do all the work to allow airflow into my attic, or my ceiling. And some factories will actually do an assembly where they'll install panels at the top, so it's half of a hinged roof and half panelized. But then again, I have the same problems. I have to do a flip, I have a solid blocking, and I have to make sure I have airflow, because I have to have airflow from the eaves to the peak. One of the last ways the factories will do it is they will actually create a hinged roof, but they will do panels at the top. So once I lift that roof up, attach it to the end wall panels to support it, I will have panels that I will drop in. When I install those panels, I still have the same problem I have when it's a flip. I typically will have solid members that don't allow airflow, so I'm going to have to drill those, allow airflow to go through from the peak to the eaves.